Well, underground fuel tanks are basically a ticking time bomb. They're a steel tank put underground, connected to a bowser with steel lines and vents, and all it takes is one part of that system to fail and you can end up leaking fuel into the ground. Durai is just a little town about 15 minutes south of Tamworth in central New South Wales, and Durai had a post office that, like lots of small towns, had a couple of petrol bowsers out the front to sell petrol and diesel to the local community. Durai has no reticulated drinking water system, so all of the residents there rely on both rainwater running off their roofs into tanks and groundwater, so lots of the houses have their own bore. During the drought about a year ago, some of the bores surrounding the post office started pulling up some slightly smelly water, and one particular residence pulled about 200 litres of fuel from their bore in and put it into their drinking water tank. So ENV got a call to come and investigate, and the first thing we did was look and see what the source of the contamination was, and it was pretty evident with only one fuel station in the town that we knew where that was coming from. The second issue was looking at the groundwater source. Now, all of the bores in the town were roughly 40 metres deep, which is quite deep for fuel-based contamination to reach down. So this obviously wasn't a new leak. This was a long-term problem that had been found. We also looked at, together with the council, we started sampling everyone's bores around the town to see if we could see how far the contamination had spread. And at this stage, we found water that was contaminated up to about 150 metres from the source. But later on, we actually found sources up to 300 metres away that were also contaminated. In identifying the problem, we've actually got to look at the data gaps that we have and do an analysis of what we know and what we don't know. So we knew the source was potentially the fuel station, the underground tanks, but we didn't know how far it spread. We needed to go and drill some more bores around the site to basically delineate where the contamination was and wasn't. In terms of formulating a solution to the problem, we had a collaborative process which involved the local council, the fuel system provider, and the Environment Protection Agency, and us as the consultants. And we looked at what easy wins we could have in terms of removing the source of the contamination, so the tanks were removed. But that was a process all by itself, in that the tanks were very close to the building, so we had to underpin the building, so we had structural engineers and builders come in and make sure that the building wasn't going to fall down. So then we could remove the tanks and remove the grossly contaminated material down to bedrock that we could get. So once we'd removed that material, then we know that there's no more fuel actually going into the ground there, and then we can start coming up with a remediation solution. We did some brainstorming about the actual type of geology and the type of aquifer that we were dealing with in that site, and it's a really tricky geology to try and do any remediation in. So we're dealing with a siltstone, a fractured rock that basically has fissures, and as the contamination hit the bedrock and started moving down, it follows these cracks in the rock and moves in all different directions, and it's very difficult to actually ascertain where the plume was going to go. We also had to contend with the fact that people continued to draw through their bores and irrigate, and that was actually tracking the contamination in different directions depending on who was pulling more water and pulling harder from the aquifer. So we had very tricky conditions to try and conceptualise and put a site model together so that we could come up with a solution. Our chief environmental scientist is a toxicologist, so he's actually looking at pathways and the receptors and for the contamination. We've got a geologist who's a specialist in looking at fractured rock and trying to map fractured rock and work out where the contamination's going. And then we've got hydrogeologists on the team so that they can actually look at the aquifer and try and identify how this plume is moving. And then we had our remediation specialists who are then working out how we're actually going to try and remediate this problem. Within about 6 weeks, we actually conducted a detailed site investigation which tried to close up as many of those gaps as possible and identify exactly where the impacts lay. And that report was provided to all the stakeholders, the Environment Protection Agency and the local council, and together we were trying to work out the best way of managing the situation. When you're in an area with no water supply, it's critical to try and bring in solutions to that as well. So while we were remediating, we were actually removing groundwater with product in it. We were taking that into our treatment system and removing the product and cleaning it up to non-potable standard, and then we actually sent that back to some of the sites that had no access to their groundwater bores, so that they could use that for watering their gardens and irrigating their pastures and that sort of stuff. We have a product called a soil vapour extraction multi-phase extraction unit, and it couples those together in one container. This unit is designed specifically to remove hydrocarbons out of soil and out of water, out of groundwater. So when you get if you've got a glass and you put a bit of water and some fuel or some oil in it, and you shake it up, then you get a layer of hydrocarbon or oil on the surface. But with fuel, you actually get some of those products out of the hydrocarbon actually dissolve phase into the water as well. We initially aim to remove that small layer of product, the neat product, and then we need to go after the dissolve phase as well to help remediate that whole aquifer. We have these little skimmer pumps, and which we send down wells, and that's when we can see a big layer of hydrocarbon sitting on top of the groundwater, and they specifically just remove that layer of hydrocarbon. And then we send down what's called a total fluids pump, which pull a combination of dissolve phase, water and hydrocarbons out of the ground, and we treat that through our system. The neat product we put into a tank and that gets recycled, and the dissolve phase we try and remove the hydrocarbon from the water, and then we polish that water with a activated carbon filter, and then that can be then irrigated. We test it and then it can be irrigated as a non-potable water source. So the last part of our system is the soil vapour extraction, and that's where we have high levels of vapour in the soil that we need to reduce. Now, vapour intrusion can happen back into buildings, so the vapour is lighter than air and it'll actually travel up through and into buildings. We've got ostensibly a big vacuum cleaner that can actually suck the air and the vapour out of the soil. So we put specific wells around, especially where the product had gone into that ground, and maybe under the building where we couldn't actually remove the soil that was contaminated. And over a period of months, we actually pull that vapour out. Now that vapour gets pulled out by a big vacuum cleaner. It goes through a carbon filter to remove the hydrocarbons, the vapour, and then the rest gets expelled back to the atmosphere, the cleaned air. So this is a project that's probably going to be ongoing for a few years. Still got equipment out there. It's currently not running, it's just in a latent phase, and that we may start it up again when those, if we see that we've got a hydrocarbon coming back onto the groundwater. Well, ENV offer a range of solutions to help prevent this sort of issue occurring in the first place. The first is called secondary containment monitoring. So where you've got underground tanks, we install monitoring wells down into that groundwater, so that if there are any leaks, that we're monitoring them, and we can pick up those leaks quickly